Hi everyone, this is Ms. Shabanu. I hope you're all doing great. As we have previously informed you, we have prepared your lessons in some slides in order to compensate the lessons you missed due to the holiday. Stay tuned and wish you all a healthy holiday. Before we get started, I would like to give you some tips. It's not a must to watch this video at once, so take your time and please try to write down everything, the important notes and the given examples in your notebook. When I write a star, it means that note is very important. So write down everything because I will check your notebooks when we go back to school. Before the holiday, we studied 8 chapters and 2 lessons of chapter 9. So we will start from lesson 3 of chapter 9, but I recommend you to revise the first 2 lessons of chapter 9 because you will need the topics you studied in those 2 lessons. The 3 following slides are the photos of the board of those 2 lessons, in case it's necessary. Mixed numbers, page 168 to 171. A mixed number is made up of a whole number and a fraction. Examples of mixed numbers: 2 and 2/3, 3 and 1/8, 1 and 1/3. Here we have a delicious example of mixed numbers. We have 3 pizzas. Each pizza is cut into 4 equal pieces. But the third one of the pieces is missing. So I can't consider the pizza as a complete pizza and I can't ignore it. How can I represent this amount in numbers? I can use mixed numbers because the number of the whole pizzas can be represented by the whole number, and the number of pieces in the incomplete pizza can be represented by the fraction. So I can represent this amount in mixed numbers and read it as 2 and 3/4. Remember, to read a mixed number, first read the whole number and then the fraction. To read a fraction, first read the numerator and then the denominator, but pay attention, the denominator must be read as ordinal numbers. Example given 1. Write a mixed number for each picture. In the first picture, we have 4 hectagons. A hectagon is a polygon having 7 sides. So each hectagon is divided into 7 triangles and they are colored in blue. The 3 first hectagons are colored completely in blue, but the last one, we have only 4 triangles colored in blue out of 7 triangles. So how can I represent this amount? I can use mixed numbers. The first 3 hectagons are completely blue, so I will represent them by the whole number, which is 3. And I will represent the last hectagon by fraction because we have only 4 triangles colored in blue. So it's represented in fraction and read as 4/7. So the mixed number is read as 3 and 4/7. In the second picture, we have 2 circles. The first one is completely colored in blue, but in the second one, only a quarter of the circle is colored in the blue. So the amount is read as 1 1/4. 1 1/4. Sometimes the numerator of a fraction is greater than the denominator. These fractions are called improper fractions and have a value greater than 1. They can be renamed as a mixed number by long division. Example given 2, rename the fraction as a mixed number. So whenever you see a fraction with its denominator greater than with its numerator greater than the denominator, that fraction can be renamed as a mixed number by long division. Remember the steps of long division. Does McDonald's sell burgers? So if we want to write this number as a mixed number, this fraction as a mixed number, we have to divide the numerator by the denominator. And I told you during class time that fractions are like division. The numerator becomes the dividend and the denominator becomes the divisor. So 19 divided by 3, we should find a multiple of 3 which is very close to 19. 6 times 3 is 18. So 19 divided by 3 is 6. 6 multiplied by 3, 18. 19 minus 18 is 1. Here, we will need the divisor, the quotient, and the remainder to form the mixed number. The remainder is the numerator of the fraction in the mixed number. The quotient is the whole number in the mixed number, and the divisor is the denominator of the fraction in the mixed number. Comparing mixed numbers. To compare mixed numbers, start from the whole numbers. So first you should compare the whole numbers. But what if the whole numbers are different? If the whole numbers are equal. If the whole numbers are equal, then compare the fractions using the methods we have studied before. See page 166 to 167. If you see that the whole numbers are the same, then you have to compare the fractions using one of the methods we have studied previously. When improper fractions are compared, first rename them as mixed numbers and then compare them. See example given 2. Example given 3, compare each of the following. A. We have 5 and 2 sevenths and 3 8/9. Which one is greater? According to the first note, we should start comparing from the whole numbers. So we have 5 and 3 as whole numbers. Which one is greater? We all know that 5 is greater than 3, so we don't have to look at the fractions. Make your decision that 5 and 2 sevenths is greater than 3 and 8/9. B. We have 1 and 2 sevenths and 1 and 3 sevenths. Which one is greater? According to the first note, we should start comparing from the whole numbers. Both of the whole numbers are 1, so they are the same. What should I do now? We should look at the fractions. We have 2 sevenths and 3 sevenths. Let's compare them. Both of the denominators are 7, so let's just decide by comparing the numerators. We have 2 and 3. It's obvious that 3 is greater than 2. We all know that. So we can say that 1 and 3 sevenths is greater than 1 and 2 sevenths. C. We have 23 sevenths and 33 eighths. Here we don't have mixed numbers because we don't have a whole number. And if we notice, we see that the numerator is greater than the denominator. So here we will use the second note. When improper fractions are compared, first rename them as mixed numbers and then compare them. How can I rename them? By long division. So divide the 23 by the 7. 23 by divided 7, you will get 3 as the quotient, 2 as the remainder, and 7 is the divisor. And 33 divided by 8, 4 is the quotient, 1 is the remainder, and 8 is the divisor. So here we have 3 and 2 sevenths with 4 and 1 eighths. Which one is greater? We have to first look at the whole numbers. We have 3 and 4. 4 is greater than 3. We don't have to look at the fractions. That means 4 and 1 eighths is greater than 3 and 2 sevenths. Changing mixed numbers to improper fractions. To change mixed numbers to improper fractions, multiply the denominator by the whole number and add the product with the numerator, then write the sum as numerator of the fraction and the denominator stays the same. When you read this note, it somehow looks complicated, but actually it's very easy. Look, we have an example here, example given 4. Write the following mixed numbers as improper fractions. A. 5 and 2 sevenths. The note says multiply the denominator by the whole number. The denominator here is 7 and the whole number is 5. So 5 multiplied by 7 is 35. It said then add the product with the numerator. So we have 35 as the product. 35 plus 2 is 37. We got the numerator of the fraction. So just write 37 over 7. The divisor or the denominator stays the same. It doesn't change. B. We have 3 and 8/9. How can I write this number as an improper fraction? So multiply the denominator by the whole number. 9 times 3 is 27. Then add the product with the numerator. So 27 plus 8 is 35. Now write the sum as the numerator of the fraction, 35 divided by 9, or 35 over 9, you can say 35 ninths. C. We have 5 and 2 twelfths. How can I write this number as an improper fraction? We have to multiply 12 by 5 because we have to multiply the denominator by the whole number. 12 times 5 is 16. Now we have to add the product with the numerator. So 60 plus 2 is 62. Try to solve the followings by yourself. Remember, Ms. Shabanu never forgets to give you homework. So try to solve the following by yourself. Please depend on yourself. Trust yourself because I believe in you. I trust you. I know that you can do it. Do this in your notebook. Page 117, number 12, 18, 21, and 28. So solve these numbers in your notebook. Chapter 9, Lesson 4. Add and subtract fractions. This one is very easy. It takes 5 minutes to understand. To add or subtract, fractions should have the same denominator. When you have fractions with equal denominators, all you have to do is to add the numerators. And the same way for subtraction, just subtract the numerators. We have example given 1. Add or subtract the following. Write the answer in the simplest form. We have 6 over 8 plus 1 over 8. Since the denominators are equal, so just add the numerators. 6 plus 1 is 7, so the answer is 7 over 8. B. 8 over 12 minus 2 over 12. The denominators are equal, so all we have to do is to subtract 6 from 8. 2 from 8. 8 minus 2 is 6. So the answer is 6 over 12. Remember, it says write the answer in the simplest form. We have to simplify the fraction if it's possible. We studied simplifying fractions in the first lesson. You can see page 163 to 165 for simplifying fractions. Here, I have simplified the fraction for you. We have 6 over 12. We have to find the factors of 6. Which two factors, if I multiply, we will get 6. 1 times 6 is 6. Since I chose 1 and 6, I should choose factors of 12 in such a way that one of the factors is common with the factors of 6. So 2 times 6 is 12. We have the 6's common, so they cancel each other, and the numerator with the denominator cancel each other. What is left? 1 is left for the numerator and 2 is left for the denominator, so the simplest form of the fraction is 1 over 2 or half. Remember, Ms. Shabanu never forgets to give you homework, so try to solve the followings by yourself in your notebook, page 173, number 4, 8, 19, and 20. You can do it, I'm sure. Chapter 9, Lesson 5, Add and Subtract Fractions. Page 174 to 175. As we mentioned before, in order to add or subtract fractions, they should have the same denominator. But what if the denominators are different? We have to equalize the denominators by using equivalent fractions. We studied equivalent fractions in the first lesson of chapter 9. Equivalent fractions can be used to equalize the denominator. Check your notebook, page 163 to 165 for equivalent fractions. Example given 1. Add or subtract the followings. Write the answer in the simplest form. 1 over 6 plus 2 over 3. The denominators are different. One of them is 6 and the other one is 3. To make 3 equal to 6, it should be multiplied by 2. So multiply both the numerator and the denominator by 2 to get the equivalent fraction. Remember, I told you numerator and denominator are like twins. We can't differentiate between them. If I multiply the denominator by 2, I have to multiply the numerator by 2 as well. So 2 times 2 is 4 and 3 times 2 is 6. we got 4 over 6 as an equivalent fraction to 2 over 3. Now I can add the equivalent fraction with the first fraction. 1 over 6 plus 4 over 6. Since the denominators are equal, I can add it very easily. 1 plus 4 is 5, and the denominator stays the same. B. We have 5 over 6 minus 1 over 2. We have to equalize the denominators by equivalent fractions. So how can I change 2 to 6? I can multiply it by 3. So 1 times 3 is 3, and 2 times 3 is 6. Now I can subtract the fractions. 5 over 6 minus 3 over 6 is 2 over 6. We have to write the answer in the simplest form. We have to simplify it. Write the factors we have for 2 and the factors for 6. The 2's are common, they cancel each other, so only 1 and 3 are left. So the simplest form of the fraction is 1/3. Try to solve the followings by yourself in your notebook, page 175, number 7, 11, 18, and 24. Hey, you can do it! Chapter 9, Lesson 6, Add and Subtract Mixed Numbers. It's very easy. Page 176 to 177. To add mixed numbers, add the fractions first, and then add the whole numbers. Write the answer as a mixed number. Same way for subtraction. Example given 1, add or subtract. We have 1 and 2 over 4 plus 3 and 1 over 4. First we have to add the fractions together. So we have 2/4 plus 1/4. Or you can say 2 over 4 plus 1 over 4. And since the denominators are equal, it's very easy. Just add the numerators. 2 plus 1, 3. So we have 3 over 4. Now let's add the whole numbers together. 1 plus 3 is 4. We have to write the answer as mixed number. The whole number is 4. The fraction is 3 over 4. So the mixed number is 4 and 3/4. B. We have 3 and 2 over 3 minus 1 and 1 over 3. We have to subtract the fractions first, then the whole numbers. 2/3 minus 1/3. Since the denominators are equal, all we have to do is to subtract the numerators. 2 minus 1 is 1. And the denominator stays the same. So the answer is 1/3. Now let's subtract the whole numbers. 3 minus 1 is 2. So we have to write the answer as a mixed number. The whole number is 2 and the fraction is 1/3. Just write them next to each other and that's it. The answer is 2 and 1/3. Very easy. Try to solve the followings by yourself, page 177. Number 2, 8, 10, and 16. You can do it. You're strong. You're genius. I believe in you. Trust yourself. Thanks for watching. Love you all.